What is up, plant people? Hey, it is Tuesday again, and that means it's time once more for the Planthropology Podcast, the show where we dive into the lives, careers, and general awesomeness of some very cool plant people. I'm Vikram Baliga, your host and your humble guide in this journey through the plant sciences. And as always, I am so very excited to be with you today. Not least of all because we're starting a new series today, and I'm really excited about it. So you may remember that last year, well, not exactly last year, not just last year, for year 2 of the podcast, which started actually in November of 2020 and ran through the end of October this year, 2021, which is like 2020 part 2. Anyway, we talked and did a series focusing on plants and world traditions. We looked at everything from caffeine to drinks and rituals and a ton of other things. It was a lot of fun. And that ran its course, and I think it was great. So I put a poll on Twitter a while back about what people might like to learn about in this year 3 of Planthropology, and y'all voted for trees. So Tree Talk starts today. Now, this series is going to be interesting. The topics will vary. I'm going to try to follow seasons a little bit and talk about what tree things are relevant in whichever season we happen to be in. But that's not always going to be the case. So I'm going to try to do this series in the way that I might teach a class about trees. Now, you are not going to get 12 months of lectures. You may want that. You're not going to get that. So I'm not teaching you a tree course. But I am going to try to cover a lot of the things that I might cover in an introductory horticulture class or a tree class. So that's typically arboriculture or something similar. Because I want to give you an understanding and a maybe working grasp of what trees do and what trees are and how you can manage the trees in your landscape. So today's episode is going to be a fairly short introduction. Most of them will probably be a bit longer than what you're going to get today. But I wanted to talk about some general concepts and what makes a tree and just talk about some of the basics. And then we'll move on to pruning and planting and site selection and lore about trees and so many other things. And if there are topics that you might want me to discuss as this goes, let me know, and I would be happy to do it. So drop me a line. Some housekeeping before we get started. Look up Planthropology all the places. I'm on Instagram, Facebook, Twitter. Search for Planthropology which is anthropology with a PL slapped right there on the front. Look for the bristlecone pine, which is my favorite tree, by the way. And that'll be me. I would love for you to connect. If you want to support the show, go over to buymeacoffee.com/planthropology. Your donation to the show, your contribution will go to making sure this thing stays on the airwaves and will most likely, honestly, just literally go to buy me coffee. So today's episode is called Trees Aren't Real. And I'm going to let you chew on that for just a minute while you listen to some music. And then we'll jump into it. So I hope you're excited. I hope you're sitting down in a nice wooden chair made of a tree. It's maybe a little morbid for this, but that's okay. And prepare your ear holes for episode 1 of Tree Talk. Trees Aren't Real. Okay. So I feel like the reasonable question that at this point you must be asking yourself after that introduction is, trees aren't real? Really? Because I'm pretty sure I've seen a tree and you have seen a tree. So I say that a little bit tongue in cheek. There is this concept in biology that the way that we classify things is not necessarily arbitrary, but may not mean quite as much in a biological sense as sometimes we like to act like they do. So I think species are a good example of that. We use the word species to categorize and group plants, or not just plants, but organisms based on common characteristics, on the way that they develop and grow and mature and interact with their environment and all of the things that makes an organism an organism. And if they're similar genetically, behaviorally, phenotypically, we typically put them in as a species. This is a species. This is Felis domesticus, or this is a certain type of fish. I don't know anything about fish, or I would throw in out there catfish. Whatever the scientific name for catfish is, Catus fishicus. Please don't tell anyone I said that. Anyway, does that mean anything? Yeah, yes and no. Yes and no. Okay, so it is useful. It's useful in a lot of ways. When we communicate about different organisms, different types of life, it is meaningful to be able to know that we're talking about the same thing. So when we talk about Latin names and species names and all that, if we throw those around and there is a common standard for what those words mean, I need y'all to remember as we get through this that words mean things. They really do. Then the people that are communicating know what they're talking about. When I say Felis domesticus, like the common house cat, there is a wide variation in phenotypes and the way they look and their physical expressions of their genomes and things like that. But in general, when I say house cat or cat, you know what I'm talking about. The lazy piece of garbage that I'm looking at through my window laying on the table outside my office. He is a big orange pumpkin loaf, and that's about what he does. He loafs around and he looks like a pumpkin. Anyway, that's Ganymede I'm talking about, by the way, our greenhouse cat. He's not worthless. What's the next thing closest to worthless? He is a very friendly cat, and he does what cats do, and he lays around. Anyway, when I say house cat, some of those images come to mind. So you know what I'm talking about. This is the heart of communication, right? We make mouth sounds at each other, and our ear parts take those mouth sounds and put them in our brain and develop some kind of picture, some kind of categorization. But when we really drill down to it, maybe species doesn't mean as much as we think it does, or that we portray it to mean, because those lines get a little bit blurred. Where does one species stop and the next species start? And when we look at different species, what are their common ancestors? Where do they come from? When we talk about relations between different species, it's, a tuna is more closely related biologically, genetically to you than it is to a shark. There is divergent branches of evolution and all these things that lead to what we call species, and it's fuzzier than we like to pretend it is. But it's still useful. It's still useful. So when I say that a tree doesn't exist, I mean it, but I don't mean it. So let's talk about this. If you look at a phylogenetic tree, I started laughing before I got that joke out. That is a good picture of my life. Anyway, if you were look at the phylogeny of plants, and the phylogeny is the categorization of their ancestry, their characteristics, where they live in this grand scheme and this grand thing that we call life and existence. So if you look at the phylogeny of plants, there's not a phylogenetic group that just says tree, right? Tree is more of a utilitarian term than it is a biological term. So if you really look it up, the thing that makes a tree as we know it and as we consider it is that it's a plant with woody growth, so secondary growth. You when I say wood, you know that like it means bark and this hard lignified or strong structure in the stem of the plant or in the branches of a plant with an upright growth aspect. It's a perennial, and that's about it. So when I say tree, it's a perennial plant, lives multiple years, has wood, and it grows mostly upright, has a single upright growth aspect, except when it doesn't, right? So let's take a red oak. A red oak is a great example of this. So a red oak, if you've never seen one or had the pleasure to meet them, is a beautiful tree. They are often single trunked. I have one in my backyard that I can't nearly get my arms around. It's probably 40 feet tall. It's a beautiful red oak. But then my neighbors across the street have a red oak that has 5 or 6 trunks. Now, sometimes when you see a multi-trunk red oak, it's because they grew multiple acorns in the same pot and they all grew up next to each other and that wood fused and you've got multiple trees. But a red oak can also grow as a multi-trunk tree. So it does not have a strictly upright axis, growth aspect. So is the multi-trunk red oak not a tree anymore? What is it then? Is it a shrub? What's a shrub? We don't know what a shrub is. A shrub is typically considered a woody plant that does not have a predominantly upright growth aspect. It branches, and it is, for lack of a better term, and you should never use a word to describe a word, but it's shrubby. And you know what I mean when I say that, right? It looks like a round or scraggly little bush that is not a tree, but it's woody. It's perennial. It's generally upright. So we kind of split hairs a little here, okay? And I think this is important to understand because when I say this is a tree, it puts a very specific picture in your head. So let's talk about a palm tree, right? We call it a palm tree. Is it perennial? Yes, it is. Does it have a single axis that is mostly upright? Yes, it does. Does it have wood? Not really, no. No, it's more closely related to a big grass than it is an oak tree, but it has the same growth aspect in general, so we call it a tree. So the point I'm trying to make is that the word tree crosses multiple branches. There's going to be a lot of tree puns, y'all. Just buckle up. On our phylogenetic chart, it spans a lot of categories. So when I say a tree doesn't exist, I mean that there is no one place that I could say this is where trees live, because trees are in a lot of different groups and they live in a lot of different places. But there are some things as we talk about trees that they do share across the board. And I want to give you a little bit of information about some things that we commonly consider parts of a tree or the physiology of a tree, okay? And a lot of this information that I'm going to be sharing with you comes from the Colorado State Forest Service. And there's a lot of places, but this is a great resource for all things trees, especially conifers and evergreen trees. And if you look at their website, there's an article that I'll link in the show notes that is, what is a tree? How does it work? Which is what I'll be talking from right now. And the picture that they show at the top of this article, I've actually taken this same picture from the same place. And I'll talk about that more when I talk about places to see trees, which is maybe funny. I live in part of the country where we don't do that. We don't see trees. But let's talk about some different things. Okay, so tree physiology first. A tree is a tall plant with woody tissue. Okay, cool. Trees gather light for photosynthesis because they're a plant, and that is how the plants do. And it creates food for the tree. The tree, as it grows, puts on woody secondary growth. Most of the trunk of a tree is dead. They're zombies. I have a friend named Jordan that this totally blew his mind. He still talks about it sometimes, that like 96% of a tree is dead. Because the inside of a trunk, the inside of the branches, as that wood ages, those cells die. And your growing points are at the tips of the branches, the leaves, and the outside of the stem. Okay, so we have this cambial layer that has the xylem, which moves water in general up the tree from the roots, and phloem, which moves carbohydrates and other compounds from where they're produced in the leaves and other tissues down to the rest of the structure. And that is just around the outside. Most of the tree is dead tissue that holds up the living portions. Okay. So if you were to take a tree and cut it down, I don't know if I've talked about this on the podcast, but I'm a woodworker. So I'm really interested in the way that trees lay in and develop wood. I think it's really interesting. But they have heartwood near the center, which tends to be darker in color, a little bit more dense, a little more solid. And then there is sapwood, which is closer to the outside. Now, in general, all of these tissues are dead tissues, but they age differently and their characteristics are different. So we use sapwood and heartwood for different things in woodworking and in construction that uses trees and plants. Okay. So every year trees grow annual rings. Usually there's two. There is a wider and thinner walled layer in the spring called springwood. It grows faster at that point in the year. And in the summer you get a thicker walled layer, usually fairly thin in nature, that is called summerwood, and that develops during the summer. Trees have the same general parts as most plants. They have leaves, they have branches, they have a crown, which is the above ground structure of a plant in general, but we would generally consider the crown of a tree to be the canopy and the area surrounding the canopy where the leaves, twigs, branches, flowers, and fruit are. Okay. Flowers, like all plants or all angiosperms or flowering plants, are the site of reproduction. Trees can be either male or female or both or something in between all of the above. We will talk about some plant genetics and tree genetics as this series goes on. Conifers are a little bit different. They don't have typical flowers. They don't have those fruiting structures. They are called gymnosperms, and they produce cones, which have the seeds in them. They're a little bit different. Trees have trunks. Trees have bark. Trees have roots. And again, they grow out from the tips and out from the outside of the stem. So there are some general things, again, that we just went over that trees have in common across species, across parts of the world, biomes, ecosystems. In fact, it's thought that trees have evolved over and over and over throughout time in different places. And there's some evidence that early plants were more tree-ish in nature with more secondary growth, and that some of our herbaceous annual plants were a later development. So let's think about this from a biological standpoint. You are a plant, and you are surrounded by things that eat plants. What do? How do you protect yourself so that you live long enough to reproduce and make more plants? There's some different strategies. And one of the strategies that I kind of think that trees employ is they got tall. They got taller and they moved their leaves and fruits and the parts of the plant that were generally eaten farther off the ground. So it made it harder and harder for their predators, whether these be large dinosaurs, sauropods, animals that would climb up the tree, and all of these things. There's a lot of things that want to eat the leaves off of a plant. So as these plants grew taller, it got harder for that to happen. But oh no, our trunks are exposed. The fleshy growing points that we need around the outside of our stem to keep living are exposed and vulnerable to animals and herbivores. So what do? Well, it's probably true that the plants that had more lignified, strong trunks that, animals could not eat as easily were the ones that survived. And then the next generation would have slightly stronger stems and so on and so forth. And voila, the mysteries of evolution happen. And we have selected for tall plants that have their leaves far away from the ground and a strong woody trunk. And then over time, plants developed other strategies for protecting themselves. And then they didn't have to get so tall. They didn't have to get so woody to stay safe. They came up with chemicals and thorns and smells and coevolutions with the predators of the things that wanted to eat them and all this different stuff to protect themselves. Evolution, my friends, is an arms race. And it is an organism either trying to stay ahead of its predator or catch up with its prey. And it drives species forward. And it drives it in unique ways in different places. But because of these unique characteristics and the way that herbivores tend to eat plants, we see trees popping up over and over and over throughout time. Move over, crabs. Carcinization is so last year. Now it's dendronization. And we're all becoming trees in the end. So when I say trees don't exist, does that mean that I'm going to stop calling things trees? I'm absolutely not. That's not productive, is it? I don't think it is. Because if I start to have to go into this whole explanation of, a tree is a plant with woody growth and a single axis, and the leaves are up here because dinosaurs and all of this stuff that I've been talking about, every time I want to talk to someone about my oak tree, I'm not going to, for one, have many friends left, and two, I'm never going to get my message across. So we use in science communication words like tree and species, and a lot of things that, while they're maybe not 100% accurate and they're not as meaningful as some people think they are useful because they allow us to communicate clearly and without pretense to other people. So don't stop calling things trees, because when you say tree, when I say tree, When the Lorax says that he speaks for the trees, we generally know what each other are talking about. And that is important and that is meaningful for society and science communication in general. So that was just a quick primer on some of the basic physiology of trees, some of the issues surrounding the word tree, and I thought an interesting opener for this series. Oh, one more thing that I wanted to mention. So as I was doing research for this and making sure I'd had a few of my terms straight and facts straight, I ran across this article, and a few articles actually, one first and then more and more. And y'all, this is wild to me. I'm just going to read the title of this article real quick from The Atlantic. And I hope you're sitting down or in your car, or I need you to prepare yourself. Flat earthers have a wild new theory about forests. And the subline here, the subheading is what it means to believe that real trees no longer exist. So y'all, I don't want to give this too much airtime, but essentially there are flat earthers that look at mesas and other rock formations like Devil's Tower that, okay, maybe that looks a little bit like the trunk of a tree. I'm looking at a picture right now. And say that, oh, these are ancient forests and there were like 5 trees on the planet. And then at some point there was some like nuclear alien war or something and all the real trees. I don't know. Some of this stuff is so bizarre to me, but be careful maybe who you say trees don't exist to, because you may get an earful from a flat earther. And if it is not clear the world is round, this is a Globe Earth podcast, Globe Earth friendly podcast where we believe in things like that. Anyway, so that was funny to me, and that will never not be funny to me, that the new flat earther thing, and this article came out about 5 years ago, so it's not that new, is that all the real forests are gone and we're left over with cheap imitations. I would like to see you tell that to a redwood or to Treebeard. Would be good. Anyway, I hope you all enjoy this series. Please, if you have questions or other tree-related material you'd like me to cover, send it my way. Again, you can contact me on Instagram, Facebook, Twitter. You can even find me on the TikTok machine as @ThePlantProf, where I took and left the rest of my self-respect. Thanks so much, as always, to the Texas Tech Department of Plant and Soil Science for supporting the show and letting me do fun series like this and just talk about biology and trees and all the good things out there. Thank you to you, the listener, for being so wonderful, for taking part in this podcast, for being engaged on social media. If you don't mind heading over to Apple Podcasts or to Podchaser and leaving me a rating and review, I would very, very much appreciate it. I really would. Maybe that's not the be all end all. Maybe it doesn't actually do anything to promote the show. It depends a little bit on who you ask, but it makes me feel good in my squishy meatbag heart parts. And I like to know what you think. I wear a size 5-star review. Christmas is coming up. If you would like to get me a gift, that's what I would like. But also, if you'd like to send me an email with some criticisms, I'm happy to address them, and I'm happy to hear what you have to say. It's planthropologypod@gmail.com. Anyway, as always, you know I love you folks just so much. I hope you keep being cool plant people. I hope you keep being kind to each other. And if you haven't been kind to each other, I hope you start being kind to each other. And I'll talk to you real soon with more great plant content.